Question number 1. So a closed box of fixed volume 0.15 meter cube contains 3 moles of ideal monoatomic gas. Okay, now what is being given? The volume is given here, number of moles is given here, and temperature of the gas is given here. Calculate the pressure of the gas. So how do you do it? You can use the equation PV is equal to nRT. Okay. Because he says it's an ideal monoatomic gas, you can always use your equation, that is the ideal gas equation. So you have to find out the value of P, which is equal to nRT divided by V. So what's the value of V? N is 3 and R is 8.31 multiplied by temperature is 290 Kelvin. It's already given in Kelvin. You need not convert everything. 290 divided by volume. Volume is 0.15. So calculate this in calculator. 3 into 8.1 multiplied by 290 divided by 0.5. Decimal place is not. Let me do it once again. 3 it's 48,198. 48,198. Now you see this is two significant figures everywhere over here. I'll keep it as 48 kilopascals. Let me move on to the next one. When the gas is supplied with 0.86 kilojoules of energy, the temperature increases by 23 Kelvin. The specific capacity is given out. Okay. Now what is this? Let us take up this value. So this is your energy. This is your increases by, means delta T is given. Specific capacity is given. So which equation will you use? So we can use Q is equal to MC delta T. M has to be found out. So all these are very quite easier questions to work with. So see, delta T, Q is nothing but 0.86 kilojoules. Second item is 860 joules divided by C. C is 3.1 into 10 cube, right? So this should be 3,100 multiplied by 20. This would be 100. So much divided by 23. This is 0.012. What is this mass over here? It should be in kg. It should be 12 grams. Okay. Next, calculate the average kinetic energy of the particle. Average kinetic energy of the particles of the gas. That is the average kinetic. So how do you calculate the average kinetic energy? Average kinetic energy is given by P by 2 times kT. So this will be your kinetic energy average, which will be P by 2 multiplied by K is 1.38 to 10 power minus 23. This will be in your data booklet. Multiplied by temperature. See, you should not use 23 Kelvin here. Okay. So you should use the absolute value of it. So it is 290 plus what is the temperature it was raised over here? It was raised by 23. So it should be 290 plus 23. Okay. So this is one mistake which many students have done it. I gave them in their test paper. See to it that you do not do the same thing. So 3 by 2 into 1.38 and 4 minus 23. 3 multiplied by 290 plus 23, 1513. So do this. Answer as 1.5 multiplied by 1.38 multiplied by 313. Give me 647.91. 648. 648. Did I miss anything over here? No. Into 10 power minus 20 joules, or I should be writing this as 6 point, how many, 2 significant figures, like 6.5 into 10 power of minus 20. explain with reference to the kinetic model of an ideal gas how an increase in temperature of the gas leads to an increase in the pressure. Okay, it's for 3 marks, so definitely 3 points are essential. The first point you can say is that when what is happening, kinetic model, how an increase in temperature. When temperature increases, what happens? The speed of the molecules increases, or you can also say that the average kinetic energy of the gas increases, right? So when the average kinetic energy of the gas increases, all of this has a chain effect, right? An average kinetic energy, what happens? The momentum increases, right? Momentum of the particles increases because kinetic energy is p squared divided by 2m. Momentum increases, and this in turn what happens? This implies a change in momentum over time. What do you call this as? Force increase. And then finally, the force increases. What happens? Pressure increases. Okay. So finally, pressure increases. We all know when temperature increases, pressure will increase. If something is not known clearly, since it is asked for 3 marks, you definitely need to write a story. Next. Only one question for today, and tomorrow we will see the next question. Thank you.